All right, as we continue on with our discussion of waves, so we've already talked about transverse waves. Now I want to talk about compression wave. A compression wave is a different kind of wave, and there's actually more categories of waves we can talk about, but we won't get to those today. A compression wave looks like, what does it look like? It looks like this. So notice what's happening here is that the particles are now moving parallel to the direction that the wave moves. Remember, with a transverse wave, the particles moved perpendicular. So let's go back real quick and look at the transverse wave where all the particles are moving perpendicular to the direction of the wave, right? Up and down versus left and right. Now when we get to a compression wave, the particles are moving left and right, and the wave moves from left to right. So those two directions are parallel to each other. Again, notice you can clearly see that there's a wave moving across the screen. It's fairly obvious that that's happening. You can see that with your eyes. And if you're not careful, it looks like there's actually particles that are moving that way, but they're not. Let's keep our eye on this one right here, and it's simply going left and right, back and forth. It does not change its position. So once again, waves transfer what again? Waves transfer energy. They do not transfer matter. One of the best examples of a compression wave is a slinky. If you have a slinky at home, just do this. Have your little brother and sister hold one end of it, and all you have to do is just compress it, and those compressions will travel down the string, the slinky, and that's a compression wave. Notice this is not a transverse wave. You can make a transverse wave with a slinky. You would have to move the slinky back and forth like this, but this one is a transverse or a compression wave. The best example of a compression wave you need to know is sound. Sound is our most common example of a compression wave. It's really hard to visualize sound because it travels so fast, but this is a special video that's taken using special imaging techniques of a person clapping. And you can see in slow motion, if you look really closely, there are compression waves of the sound of his clapping traveling outward from his hands. So you can see those waves traveling from his hands outward. And again, taken very slow motion with a very, very specialized technique. Normally you cannot see sound waves, but sound is the most important example of a compression wave that you need to know. Some earthquakes are also compression waves as they go through the earth. And I don't really want to say a whole lot more about that. There are lots of different types of earthquakes, tsunamis, earthquakes going through different parts of the earth, and not all earthquakes are compression waves. Some of them are transverse waves, but some of them actually are compression waves. Okay, so that's basically all I want you to know about a compression wave. It's not quite as complicated, so I'm really not going to tell you that much more about it.